Once again, good morning. Our topic today is about quadratic inequalities. And as I mentioned a while ago, we are down to the last topic for chapter 1. Now, to start with, let's say our memory verse all together. It's found in Romans 2 verse 11. It says, "For God does not show favoritism." It reminds us today that God is fair and equal to everyone. And your MBCA boosters is to find for a Bible text that tells us that God does not show any favorites. At the end of today's class, we'll be able to illustrate quadratic inequalities. Number 2 is to solve quadratic inequalities. And number 3 is on problem solving. Let's have a very brief overview of what is a quadratic inequality and how is it different with quadratic equation. It's very simple actually. A quadratic inequality is an inequality. It means it has an inequality sign. What are the inequality signs? The basic are greater than, less than, greater than or equal to, less than or equal to, or not equal. These ones are the basic signs. That contains a polynomial degree of 2. It means the highest exponent is 2. It can be written as any of the following forms. The quadratic expression greater than 0 or less than 0, or greater than or equal to 0, or less than or equal to 0. And remember, A, B, and C are real numbers, and A should never be equal to 0. So again, how is it different with quadratic equation? If a quadratic equation is written as x squared plus 4x plus 12 equals 0, in a quadratic inequality, it can be written as x squared plus 4x plus 12 greater than 0. That is an example. Give me a minute for a while. Now, let's have our venture activity. Instead of red or blue, we'll have it as heart or crying face. So you prepare your emojis, your heart, and your crying face. What will you press? You press heart if the one that I will encircle is a quadratic equation. But if it's not, if it's a quadratic inequality, you need to press a crying face. Ready? Let's start. Let me see our gallery for today. We have more. Okay, there. It's the same with this one. Let's start. Ready? Heart or crying face? Number 1. Heart or crying face? Let us check. Oh, very good. It's a heart. It's a quadratic equation. How about the second one? Heart or crying face? Let me see. Heart or crying face? Very good. It's a crying face. It's an inequality. Next, number 3. Heart or crying face? Heart or crying face? Let me check. Actually, the answer is it's a crying face. Very good. Next, number 4. 15 minus 6h squared equals 10. Heart or crying face? Let me see. It must be a heart. It's a quadratic equation. Next, this one, number 5. Number 5, r squared plus 10r less than or equal to negative 16. Heart or crying face? Let me check the answers. Very good. It's a crying face. Next, number 6. Number 6, 4x squared minus 25 equals 0. Heart or crying face? Very good. It's a heart. Next, number 7. Here, 3w squared plus 12w is greater than or equal to 0. Let's see the answers. Very good. It is a crying face. And the last one, number 8. M squared equals 6m minus 7. Heart or crying face? Let me see the answers. Very good. It's a heart. Okay, very good, everybody. Most of you got it right. So I think most of you will get 5 points for our first quiz today. Now, let's continue. What are examples of quadratic inequalities? You look at the left side. 2x squared greater than. X squared less than. 3x squared greater than or equal to. X squared less than or equal to. And here are non-examples of quadratic inequalities. 2x squared but equals this one. There is an inequality, but you look at the exponent. It's 1. So we call it linear inequality. Then we have the last one, the same. There is an inequality sign, but the exponent is not 2. So therefore we call it linear inequality. Now, how do we solve for quadratic inequalities? Here are some steps. It's a 7-step method. It's quite long. And in your quiz, you need, in your quiz and in your activity, you need to do it step by step. I need to check it in every step. So, step number 1. In step number 1, we need to write it in standard form. How do you know it's in standard form? The inequality is greater than or less than 0. 0 must be on the right-hand side. Next, in step number 2, we need to solve for the roots. It's up to you again. You can do extracting the square roots, factoring, completing the square, or it can also be quadratic formula. Next, in step number 4, we plot the points. So we need to have the number line. In step 4, we test a number. We call it the test point. Then the same with number 5. And in step 6, we graph the inequality. And in step 7, we write the solution set. Now, how do we graph the inequality? If we have greater than or equal to and less than or equal to, we need to shade the circles. But if it's greater than or less than only, the circles remain unshaded, or sometimes we call it open, and this one we call it close. Now let's start. Ready? Let's start with the first one. Find the solution set of negative x squared plus 1 greater than or equal to 0. Remember, in the standard form, our a should be positive and the other one should be 0. So this is correct. However, the a is not positive. So what do we do to make it positive? The whole.
Move it.
Oh, we don't move. Yeah, it's one way you could move it. But another way is you could multiply it all by -1. So the sign will automatically change. But remember, when we multiply an inequality by a negative sign, the sign of the inequality will change. So from greater than, it becomes less than. So here's now our inequality in standard form. Next, let us solve for the roots. Let me use extracting of square roots here, okay? Let's have x squared. Ma'am, how to do it? Actually, it's the same as the equation. So first, we write it as equal sign. Then x squared is equal, transfer to the other side to 1. We extract the square roots of both sides. So square root of the left and square root of the right. So we have x equals, what's the answer for the square root of 1? In your chat box, what's the answer for the square root of 1? They're still missing. Okay, do not forget, okay? Plus and -1. Again, the roots are +1 and -1. Now, what do we do next? In the next step, we will have the number line. Remember, our roots are 1 and -1. So we draw the number line. -1, 0, and 1. Remember, our roots are -1 and 1. Why did I draw open circles? Because this is a greater than. Remember, in greater than, the circles will be open. Now we test the interval. With this number line, we have divided our number into 3 points. This is 1 point. This is another point in the middle. And the last is after the circle. Sorry. So what do we do? Since there are 3 points, the first, this one, is called x less than -1. The middle is called between -1 and 1. The last is x is greater than 1. Do you have questions? Yes, AP, what's your question?
Why is there a -1 x and +1 in the middle?
Oh, remember, our roots are -1 and 1, right? These are our 2 roots. So here it's -1 before, the middle, and the after. Any other questions? Now, let's have the 3 intervals here. Ready? The first interval is x is less than -1. We need to choose a test point. What's a test point? A test point is any number that you can find in this section, in the before section. So what number can you find before -1? It can be -2. Ma'am, what if my answer is -3? No problem, as long as it's before -1. Next, in the middle test point, -1, x in the middle, it's between -1 and 1. What's the number between -1 and 1? Say our test point can be 0. Ma'am, what if my answer is a fraction? No problem. It can be 1/2, it can be -1/2, as long as the number is between 1 and -1. The last interval, we have x is greater than 1. What's our possible test point? What number is greater than 1? It can be 2. Next, in the next part, we will substitute. We will substitute our test point to our quadratic equation. Or remember, this one is equivalent to x squared minus 1 less than 0. Now, you can choose whether to have it in the original or in the next one. I prefer the final, the standard form. So we substitute it to our standard form. So that's x squared minus 1 less than 0. Let us substitute. -2 squared minus 1 less than 0. -2 squared is 4. 4 minus 1 is less than 0. So 3 is less than 0. You look at this one. Is it true or false? Is 3 less than 0? Any answers? Is 3 less than 0? No, right? Therefore, we write false because it's not correct. Let's go to the second test point. Substitute. Yes?
Question sa ma'am.
Okay.
Why is there -2 man? It's x squared. It's x squared, not 2 squared.
Here, what's the value of our test point, AP? The value is -2.
2. Oh, okay, thank you.
Okay. Next, our next test point is 0. So we substitute 0 to our x. So 0 squared minus 1 less than 0. 0 squared is 0. So we have -1 less than 0. Is -1 less than 0? Yes, right?
True.
Okay, very good. So we place true. The last one, the last test point, 2. We substitute 2 to our equation. So we have 2 squared minus 1 less than 0. 4 minus 1 less than 0. 3 is less than 0. Is 3 less than 0? True or false? It is?
False.
Okay, very good. It is false. So we now see false, true, and false. Now let's go to the next one. We test the roots. We test if the roots are included in the solution set. Here's the technique. If we have greater than or equal to and less than or equal to, the roots are included. Therefore, we shade the circles. But if it's greater than or less than, the roots are not included. It means the roots cannot be your answers. So we remain the shade open. Now let's go to graphing the inequality. -1, 0, 1. Okay, we have a circle here, a circle. They are not included, so we remain it open. Now we go back to our previous slide. Which one is true? This one, right? The middle portion. So only the one that is true can be shaded. So let's go to this number line. So we can only shade the one in between. This is now the final graph of our inequality. Then how do we write the solution set? We say x such that we go back. How do you write the middle? -1 is between x. X is between -1 and 1. Or here's another way to write the solution set. If it's open, we use parentheses. If it's shaded, we use braces. Now, we write it this way, from -1, comma, to +1. That is the answer. Do we have any questions before we go to the second inequality? Okay, let's have more practice. Ready? Let's go to exercise number 2. Find the solution set of x squared plus 7x plus 12 equals 0. A is positive, check. 0 on the other side, check. Therefore, it's already in standard form. That's x squared plus 7x plus 12 greater than 0. Let's solve for the roots. Okay, the roots. Can you tell me how do you factor? What are the factors of x squared plus 7x plus 12? In the chat box, you type the factors. If I say factors, it should be this one. Okay, not the roots. I'm not yet asking for the roots. I'm asking for the factors. Very good. X plus 4 and x plus 3. Very good. Now, let's solve for the roots. What are the roots? Can you tell me in the chat box? What are the roots? Very good. That's -4 and -3. That's x plus 4 equals 0. X equals -4. X plus 3 equals 0. X equals -3. So our roots are -4 and -3. Okay, next, what do we do with our roots? We will graph. We will plot our number line using the roots. Actually, I don't write all the numbers in the number line. I just write the roots. -4 first, the -3. Here, greater than, so open. Now, how will I write the intervals? The first one, the before, x is less than -4. In the middle, -4 less than x less than -3. In the after, that's x is greater than -3. Now let us check with our test points. X is less than -4. What will be your test point? In the chat box, can you tell me what's your test point?
7.
7. Is 7 less than -4? Oh, very good, Jared. That can be -5. Yes, Ahava. Questions?
No, ma'am. -6, ma'am.
Yes, -6. You can have -5, -6, -7, any number, as long as it's before or less than -4. Anyways, even if you have different numbers here, your remarks, the true or false, will still be the same. Next, what's between -4 and -3? In the chat box, what's between -4 and -3? Oh, very good, Isabel. It can be -3 and 1/2 or -3.5. Very good, Tatiana. Oh, AP, you could not have 0 because you could not find 0 between -4 and -3. But in the last one, x greater than -3. Okay, think of a number that's greater than -3. Type in the chat
Negative,
box.
oh, -2.
Oh, very good, AP. It can be -2. Yes, Ali, it can be 1. Or, you know what, my favorite? My favorite is 0. Because when I'll have 0, it's easier for me to solve it in the inequality. Next, let's substitute. Ready? From here, let's substitute. We have x squared. X, that's -5, x squared plus 7x -5 plus 12 greater than 0. In the second one, let's write it all first. -3.5 squared plus 7 times -3.5 plus 12 greater than 0. In the last, 0 squared plus 7 times 0. That's why it's my favorite, because most of the answers will be 0. So let's now start solving. -5 squared is 25 minus 35 plus 12 greater than 0. This is 37. 2. 2 is greater than 0. True or false? Is 2 greater than 0? True or false?
Yes.
Yes.
True.
You say true. Next. -3.5 squared. -3.5 squared is 12.25 minus 24.5 plus 12 greater than 0. -0.25 is greater than 0. Is it true or false?
False.
False. Because the answer should be positive, right? The last one, 0, 0. 12 is greater than 0. Is it true or false?
True.
True, very good. The answer is true. So you notice here, the one that is true is the before and the after, not the middle. So let's go to the next one. How do we test the roots? Again, go back to what I told you a while ago. If it's greater than or less than, the roots are not included. So we just have open circles. Then we graph the inequality. Ready? -4, open. -3, open. What is the one that is true? The before, shade it, before. And the after, shade it. Next, how do we write our solution set? How do we write this? X less than -4. This is x is greater than -3. Okay, here's how you write the solution set. X, such that you write x in the middle, -4 and -3. But here, be careful on where the opening of the mouth points. In the first one, where does the opening points? To -4 or to x? It points to
-4.
or to -4. So you open it there. In the next one, where does it point? Where does the mouth opens? To x or to -3? To x, right? So this one. There. Because if you will transfer that one like this, it is the middle, not the ends. So this is now our solution sets. Any questions? No questions? Let's go to the last one. Ma'am, what if it's not in standard form? How do you make this in standard form? You will just transfer 3 to the other side. So it becomes 2x squared minus 5x minus 3. The symbol is still the same. Again, the symbol will only change when you multiply all by -1. Then you continue. I'll give the answers and it's up to you to solve for the following. The roots. What are the roots? The roots are x equals -1/2 and 3. You can do factoring. So in the number line, that's going to be -1/2. Oops, shaded, right? Shaded. And the other is 3. Let's have it first in shaded. Oh, my answer in the module is wrong in page 50. Kindly edit the module. It should be shaded, not open, because it's less than or equal to. So in your test interval, the number here can be -1. In the middle, it can be 0. In the after, it can be 4. Then it's false, true, and false. So how do I write my final answer? The true one, -1/2 and 3. Shade, shade, the one in the middle. So I'll write it as x such that -1/2 between x. There. That's the answer.